Okay, we have another integral from the MIT Integration Meet 2025, number 4. We have the integral from 1 to e to the e, natural log x to the ln x to the x dx. Okay, there's a lot of interesting things going on in this one, particularly this exponent here. That's kind of troubling. And e to the e. Well, to get started with it, I think I'm just going to use log properties to simplify this. So not worrying about what's there, we're just going to think about that as an exponent and bring it out front. So then what we have is ln x to the x times ln x. But then we can just do the same kind of thing, bringing the x out front here. So then what we have is x, ln x, multiplying ln x times ln x, I can write this as ln x all squared. Just being careful that the square is not on the x, because then we would just bring the 2 out again. So we need to write it with parentheses. So then we'll go ahead and rewrite it. Going from 1 to e to the e, now we have just x, ln x, all squared, dx. And then from here, I think what I want to do is a u substitution, just because it's going to kind of, we could just probably go straight to integration by parts, but I think I'll do the u sub. It's going to help with the bounds. I don't know. It's probably a trade-off. So we'll do u equal to ln x, solve for x. So x is going to be e to the u, and then dx is going to be e to the u du. So when we do it, we plug in the bounds, first evaluating e to the e. So we end up, I feel like this came up on the 2020 integration bee. We plug in this here, then using that property again that we used before, bring that out front, e ln e. This is just 1, so we're left with e for the upper bound. Then you plug 1 right in there, and what you get is 0 for the lower bound. Then x is going to be e to the u. Let's kind of do this in one step. So like this here is going to be u squared. Then from here, if x is e to the u and dx is e to the u du, I can multiply those together, and what we'll get is going to be e 2u du. And at this point, I'm realizing I copied the problem down wrong. Maybe I'll keep going and see what happens. But yeah, this is not even the problem that was on the MIT. It's close. Maybe I'll do that one afterward, but this is the wrong problem. So for this, let's do integration by parts on it. So then doing that, we'll differentiate u squared, we'll integrate e to the 2u. It makes me wonder if I would still do it this way if I knew I was doing the wrong problem. Like, would I have substituted differently here? There's a lot of second guessing going on. Like, would I just go ahead and do that? No, I think it's still probably the same. So we go ahead, we'll differentiate here, and this is going to be 2u. Do it again, we get a 2. Do it again, we get a 0. Then over here, integrate, a 2 comes out. Do it again, another 2 comes out. 2 times 2 is 4. And then for this last one, we get e to the 2u over 8. So then we get our solution on the diagonals. The last row is 0, so we're not worried about that. We factor out, let's factor out, oh, you know what's troubling is I think it's going to be ugly when I plug this in. So I'm going to factor out e to the 2u over 8. And then what we're left with is going to be here 4u squared, just taking the diagonals with the alternating sign. So we got minus, then we're going to have minus 4u here, and then just a plus 2. And we need to evaluate from 0 to e. So when we go ahead and evaluate, it's going to be kind of weird. We end up with e to the 2e over 8, 4e squared minus 4e plus 2, then minus. Now when we plug zeros in, this term's going away, this term's going away, we just end up with a 2 and a 1 here. So this is going to all end up being just 2 for the inside stuff. This is going to be 1/8, so we'll have 2 over 8. And I think what I'll do is let's just reduce that to minus 1 over 4. I could leave it as a common denominator, but I think then I need to mess with this. So I think I'll just leave it and we'll call it good. That's it. Okay, so now what I'll do is go ahead and do the correct problem. Get rid of this guy. Okay, we have here an interesting integral from the MIT Integration Meet 2025, problem 4. We've got the integral from 1 to e to the e, natural log x ln x to the x over x squared dx. And hopefully I copied it down right. So now to get started with it, let's first, I think, focus on the numerator and rewrite this. So with exponent properties, I can bring this out front here. So just focusing on the numerator, this becomes ln x to the x times ln x. Do the same kind of thing again, bringing the x out, so we get x ln x times ln x, but I can write this as x ln x squared. So then when we put this back into the integral, what's going to happen? Let's see, we have this x out front, so it's x ln x all squared over x squared dx. But what I can do is cancel 1x with 1x here, so this becomes just like 1 over x. And then you can see the u substitution is going to be pretty nice, because if I just substitute for ln x, what's going to happen is derivative of ln x is 1 over x. So we have u ln x du is just 1 over x dx. So if there's like a 1 here, then everything over here to the right is going to be our du. So we'll go ahead and substitute first, plug in e to the e here. Well, that's just going to be ln e to the e. Bring that out front. Natural log e is just 1, so this upper bound just becomes e. And then you plug in 1, and it's 0. Then simplifying this, the numerator is going to become u squared. Everything else is du. And now we're just left with power rules, so we'll go ahead and integrate. Integral of this, u cubed over 3, evaluated from 0 to e. Well, the 0 is nothing. We plug in e, and for the final solution on this, we just get e cubed over 3, and that's it. Okay, so as you can see, a lot of these problems from the qualifier are going pretty quick. A lot of easy ones, especially on the early part. So that's it for today. Thanks everyone for watching. Have a good day.